I'm James Leach with the Climate Reality Leadership Corps. The Climate Reality Project was founded by Al Gore following his 2006 movie, An Inconvenient Truth. One of their primary activities is training people like me to speak in local communities and to get involved in local acts of leadership that will help make their mission a reality. There are many thousands of us around the world, more than 700 in the greater San Francisco Bay Area. If you have an audience seeking this information, be it big or small, call on us. And if you would like to be trained as a volunteer presenter, you can apply, and I can help with that. When this photo titled Blue Marble was taken on the last Apollo mission in 1972, most people were unaware that we were changing the climate. We now know the changes are threatening our very existence. Let's start with some good news. Enough solar energy reaches Earth every hour to satisfy all the world's energy needs for a full year. This amounts to only about 0.01% of the solar energy reaching the Earth. About 30% of the solar energy reaching Earth is returned to space as it strikes reflective surfaces. Remember this reflection factor because we will see later how human activity is reducing solar reflection. A very small amount of the remaining energy is captured by plants for photosynthesis and by solar electricity generation equipment. What remains is absorbed as heat. A small portion of atmospheric gases prevents some of the heat from escaping into outer space. This greenhouse effect is a good thing. Without it, the Earth would be a frozen planet. Prior to the Industrial Revolution, the level of greenhouse gases was under 0.03% of the atmosphere. This very small fraction of greenhouse gases in the atmosphere, only 3 parts out of 10,000, was just enough to create the relatively stable climate that supported the development of human civilization. As we have been adding to the greenhouse gases, the level has risen to over 0.04%, more than a 1/3 increase. Earth's atmosphere is warming, and it is destabilizing our climate. This illustration shows many of the sources of the emissions that are causing global warming. The most consequential greenhouse gas is carbon dioxide, accounting for nearly 2/3 of the greenhouse effect. Since the onset of the Industrial Revolution, we have been increasing the level of CO2 in the atmosphere as we have oxidized carbon, mostly from our burning of ancient fossil coal, petroleum, and gas. At the same time, we have been reducing the planet's capacity to remove CO2 from the atmosphere through the natural carbon cycle. The level of CO2 in the atmosphere is accelerating as more nations become industrially developed. More than 1/2 of the increase since the 1850s has occurred during the past 40 years. Methane, the main ingredient of natural gas, is a potent greenhouse gas responsible for 17% of the greenhouse effect. Ancient fossil methane escapes into the atmosphere during fossil fuel extraction and natural gas distribution and use. Methane from decomposing organic matter from agriculture and landfills also adds to our emissions. Synthetic gases are responsible for 12% of the greenhouse effect. These man-made gases enter into the atmosphere primarily from the servicing and disposal of equipment that use refrigerants such as refrigerators, freezers, air conditioners, and heat pumps. Nitrous oxide is responsible for most of the remaining 6% of the greenhouse effect. The primary source of nitrous oxide is the excessive release of nitrate fertilizers, including both synthetic fertilizers and animal waste. Nitrates that are not taken up by plants are converted by natural processes into nitrous oxide gas. The other significant source of nitrous oxide is from the combustion of fossil fuels, especially vehicles equipped with catalytic converters. Although water vapor is a powerful heat absorber, it is not considered a cause of global warming. It is instead a feedback from a warming climate. The warmer the climate, the greater the liquid water evaporated and the greater the water vapor held in the atmosphere, further amplifying global warming. Black carbon particles, measuring less than 2.5 micrometers, are released into the atmosphere from the incomplete combustion of carbon fuels. They rise high in the atmosphere and are transported on winds around the globe. Here in California, internal combustion vehicles are a significant source of black carbon. Unlike greenhouse gases that warm the Earth by holding heat radiating through the atmosphere, these solid particles absorb inbound solar radiation, reducing the reflection that would otherwise occur. This turns out to be a very significant contributor to global warming, amounting to about 70% of that of carbon dioxide, making black carbon the second largest contributor to global warming after CO2, and more than the combined effect of methane, nitrous oxide, and synthetic gases. The good news about black carbon is that it doesn't stay in the atmosphere very long. If we suddenly stopped burning fossil fuels, the level from this source would rapidly drop. Greenhouse gases, on the other hand, stay in the atmosphere for a very long time. We humans aren't very good at recognizing things we can't easily detect with our senses. All of the emissions described in this slide are beyond our perception, out of sight and out of mind. If a person is exposed to or receptive to science, it isn't surprising that they would be skeptical of global warming. Here we see global greenhouse gas emissions from various human activities as reported by the UN's Intergovernmental Panel on Climate Change. Before we focus on some of the slices in the pie chart, notice that it is expressed as CO2e, or what is called CO2 equivalent. This is a method climate scientists use to standardize how the heat trapping capacity of the greenhouse gases are described. Here's how it works. Because many of the greenhouse gases break down in the atmosphere over time, each is rated relative to CO2 for their ability to trap heat over a 100-year period. Methane is rated as 25 times higher than CO2, meaning that if the same mass of methane and CO2 were released in the atmosphere, the methane would hold 25 times more heat over the 100-year period than the CO2. Nitrous oxide will hold nearly 300 times more heat, and the synthetic gases range from as little as 5 times to well over 10,000 times more heat than CO2. Now for the slices in the global pie chart. The piece at the top, labeled Other Energy, represents the contribution from the exploration, extraction, distribution, and processing of fossil fuels. So 10% of our global greenhouse gas emissions occur before we use any of these fuels. Transportation on the lower left accounts for 14%, and agriculture is 24%. And by the way, if animal agriculture went out of the 24% slice, it would be about the size of transportation at 15%. You've probably heard the expression, think globally, act locally. This is the global view. Let's take a look at our local situation. Each year, the California Air Resources Board publishes a greenhouse gas inventory that is also expressed in CO2e. As you can see, our situation is very different from the global view, with transportation much larger and agriculture much smaller. Keep in mind that these are percentages. Agriculture appears as a small percentage because our total emissions from so many other activities are oversized when compared to the rest of the world. It is important to know what is included in this report. Other than imported electricity, it doesn't include the emissions embodied in products imported into California. If imported goods and services were included, our total greenhouse gas emissions would be much larger than what is expressed in this report. Let's look at this in more detail. Passenger vehicles represent 28%. Heavy-duty vehicles another 8.4%. And when you add in the oil and gas, pipelines, and refineries that are counted under the industrial sector, Nearly 50% of our greenhouse gas emissions are connected to our use of fossil fuel transportation. Clearly, we will not significantly reduce our greenhouse gas emissions without reducing our emissions from fossil fueled transportation. There is some really good news, as the trend lines starting in 2000 show. The top two lines show that our GDP and population have grown, while the bottom three lines show that our total greenhouse gas emissions per capita, and greenhouse gas per GDP dollar have declined. If you ask a typical Californian, you are likely to hear them tell how California is leading the way on controlling greenhouse gas emissions. This chart shows our raw CO2e by sector over this same time period. Electric power generation is the star of this chart. What started as a downward trend trailing the economic fallout from the 2008 financial crisis continued even as the economy recovered and surged. This is, of course, attributed primarily to a shift to renewable sources of electricity. California's community choice aggregation programs, such as our own Monterey Bay Community Power, have been a major factor in driving down our greenhouse gas emissions from electricity generation. We are fortunate to have electricity delivered to our homes and businesses that is generated from zero carbon sources. And of course, improved efficiency has also made a difference. The bad news is what is happening to transportation. Despite having many more high-mileage hybrid and electric vehicles, our greenhouse gas emissions for transportation are increasing. Urban sprawl, a booming economy, and an increasing number of ever larger vehicles means we are burning more fossil fuel. As we look at the relatively flat lines in many of these activities, it is clear we have been holding our own, not significantly driving down our greenhouse gas emissions. We have changed our bulbs, turned down our thermostats, and installed more energy-efficient appliances. Some of us are walking, cycling, and using mass transit more, buying locally produced goods, composting, and even seeking out ugly vegetables to cut down on food waste. We've been nibbling around the edges without committing to the systemic change required to eliminate our oversized contribution to global warming. Small, gradual changes won't be enough to avoid a climate crisis. Driving down our greenhouse gas emissions will require that we drastically reduce our use of fossil fuels in agriculture, cooking, heating, industry, and especially in transportation. We need to electrify everything, with electricity supplied through clean, renewable sources. We are fortunate today because, unlike in 2006, when Al Gore's movie An Inconvenient Truth was released, we now have the technology to affordably accomplish this goal and to do so in socially responsible and environmentally friendly ways. I'll spend my remaining time describing how our continuing greenhouse gas and fossil fuel emissions are harming us. Each of these topics could easily fill a long talk, so I'll only be covering a few of the most consequential effects. You have no doubt heard that we are on a path to an average global warming increase of from 2 to 4 degrees this century. Sometimes we hear people say that a few degrees warming doesn't sound so bad. But recognize that in the temperature scale we all understand, which is Fahrenheit. This will be nearly a 4 to 7.5 degree Fahrenheit increase. To calculate a Fahrenheit increase from centigrade, you multiply it by 1.8. If you can't remember that number, just double the centigrade increase and you'll be close enough. Also recognize that the global average is on a planet whose surface is 70% ocean. Because ocean locations have the benefit of cooler water surroundings and abundant water evaporation, which carries heat away, they will not experience nearly as much temperature increase as will locations on land, especially those well inland with an abundance of materials that hold heat and a lack of water evaporation. Heat stress is a topic that we often have a hard time appreciating. All forms of life have coping mechanisms to handle heat stress. We perspire to remove excess heat. Plants also need more water when the temperature rises. And human productivity drops off quickly as the temperature rises past a certain point. The same is true of many plants. And people who have compromised health are even more stressed by hot weather. You may recall a devastating heat wave that occurred in Russia in 2010. Tens of thousands of people were killed in that event. There have been many others with equally alarming loss of life. And as our climate warms, many areas of the planet will become uninhabitable and unproductive. Reduced ice, snow, and permafrost. Loss of reflective ice and snow will increase absorbed solar radiation, causing the planet to warm, and hastening the thawing of the ice and snow in the surrounding area and in the permafrost. The scariest part of this is the melting of permafrost soils, causing enormous amounts of methane and CO2 to be released. These gases are trapped in the ice crystals contained in the permafrost, and this will also expose a lot of additional methane and CO2 to be produced. Rising sea level. We will, of course, feel this directly here, as will the billion other people around the world who live very near our oceans. Just a few feet rise will significantly alter our coastline, even flooding areas like parts of downtown Monterey. We can see where this is headed by looking to geologic history. The last time we had CO2 levels at 400 parts per million, 3 million years ago, sea level was 60 feet higher than it is now. We won't reach that this century, but you can clearly see where we're headed. Changes to the marine biome and ocean currents. Rising ocean temperature and increasing acidity from absorbed CO2 are already altering our oceans and not in good ways. We will see continuing disruptions in ocean current norms. Changing climate patterns. The most significant change is that we can expect the temperate zones to shift towards the pole, leaving in their wake more arid land. And so the temperate parts of North America and Europe will become more arid. That'll affect the central part and southern parts of the United States for sure. Food and water shortages. Most of the world's most productive agricultural land will become less productive. As regions become more arid, freshwater sources will dwindle. Extreme weather. The strength of storms are largely driven by the unequal heating of the Earth's surface and the water contained in the atmosphere. Global warming is increasing both of these, and expect the resulting winds and precipitation to be greater and more destructive. Spread of infectious diseases and insects. The range of diseases that thrive in warmer conditions, especially those spread by insects, will expand well beyond their historic boundaries. Insects that are normally kept in check by cold weather will become more prolific. Examples include pine beetles, which have affected all of the western states, ticks, and mosquitoes. Refugees and political instability. We're already seeing the effects of this. Much of the instability in the Middle East in recent years was triggered in part by crop failures. And we have also seen how refugee immigration has fostered right-wing nationalist movements in the EU and well beyond. Pollution. Globally, many millions suffer and die every year from pollution. Because of our intense use of fossil fuels, Californians have the worst air quality in the nation, and we suffer more as a consequence. The extraction, production, and use of fossil fuels is mankind's most polluting activity. On our present course, we can expect this to become an even worse problem. Habitat loss. We aren't just talking about polar bears and our Sierra Nevada pika who are losing their habitat. We're talking about the loss of human habitat. If we don't act now to prevent the approaching climate crisis, billions of people world over will be displaced in the coming decades because of flooding, drought, wildfires, water and food shortages, diseases, and extreme heat. Please join those who are using their voices, their votes, and their choices to fight the climate crisis. Because your world depends on it. Thank you for your time and attention. The Sustainable Way is a plain-spoken 50-page booklet. It is a comprehensive source of information covering the science, economics, politics, and technology of global warming and renewable energy. And it's easy to find. Here's one of the 5-star Amazon reviews. I hope you will read the book and share it with your friends, family, and associates.